Hello guys, in this video we are going to discuss the solution of the problem majority vote. So let us look at the problem statement. The problem statement says you are given an array of integer nums where each number represents a vote to a candidate. Return the candidates that have votes greater than 1/3 of the total votes. If there are no majority vote, return -1. So for instance, if this is the nums array which is given to us, as we can see, candidate 5 and 6 are occurring more than n by 3 times, because of which we are returning 5 and 6. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is Boyer-Moore's majority algorithm. So let us discuss this algorithm and then we will see how we can use this algorithm in order to solve our problem. So let us first discuss the Boyer-Moore's algorithm. So this is a two-step algorithm. In the first step, we find the candidate elements, and these candidate elements are the one which has the possibility of becoming the majority element. In the second step, we are going to confirm where they are indeed the candidate elements. So first let us discuss the second step. So the second step is rather simple. We already know which element is the candidate element. We will just iterate on the array in order to count the frequency of that element. So to do so, all we have to do is iterate on array, count the frequency of candidate element, and if this frequency is greater than n by 3, then we are going to say that this is a majority element. Otherwise, we are going to skip it. Now let us discuss how can we find out the candidate element. So for that, let us take an example. So let us say this is the array which is given to us, and in this we want to find out the majority element. So as we can see that 1 is the majority element as it is occurring more than n by 2 times. So to understand the Moore's algorithm, first we are going to discuss with the case of n by 2, and then we will see how we can use the same algorithm to solve it for n by 3 as well. So first let us discuss the case of n by 2. So for this what we do is we first set a candidate element and then the count of that candidate element. So initially the value is 0 and initially the candidate element is -1 or some infinite value, and then we will be at the first element. In the first element, what we are going to do is we are going to set our candidate element to the first element. So the candidate element becomes 1 and the count of this candidate element becomes equals to 1 since 1 appears one time. Now the next element is 2. Now since 2 is not equals to our candidate element, because of which what we are going to do is we are going to decrease this counter by 0. And this 0 simply means till this position the elements which have appeared so far are equal, because of which the value of count is equals to 0. Now we'll move to the next element and the next element is 3. As soon as we see that the count is 0, then that simply means that we have to reset our candidate element. So let us reset our candidate element. So the candidate element becomes equals to 3, and since 3 appears once, because of which we are going to mark it as 1. The count we will mark it as 1. Now the next element is 1. Again, as we can see, 1 is not equals to 3, because of which count will be decreased by 0. And then we will move to the next element, and at this time we can see that the count is equals to 0, because of which we are going to update our candidate to 1 and we are going to update our count to 1. And in this way, towards the end of the loop, as we can see, the candidate element which we have obtained is 1, and this is what we are going to return. Please note, finding a candidate element does not guarantee that the candidate element is a majority element. In order to confirm that the candidate element is the majority element, we have to go through the confirmation cycle, which is this. So that's the general idea behind Moore's algorithm, folks. Now let us see how we can use this Moore's algorithm in order to solve for n by 3. So for that, let us take an example. So let us say this is the array which is given to us and we want to find out the candidate elements or the majority elements in this. And here the majority element will be on the basis of n by 3. So the frequency of such element should be greater than n by 3. So let us apply our Moore's algorithm to solve this. So for this, what we are going to do is we are going to take first element and we are going to take a second element. And then corresponding to this first and second element, we will have count 1 and count 2. Then what we are going to do is we are going to iterate on the array. So as of now, first is empty, because of which we are going to put the first element as 2 and the count of that is 1. And then we are going to move to the next element. So the next element is 1, and as we can see, this element is not equals to first element, and the second element is empty, because of which we are going to mark the second element as 1 and the count of that element is 1. Then we are going to move to the next element. The next element is 5. As we can see, this element is neither equals to first element or the second element, because of which we are going to decrease the count by 1. So this 2 becomes equals to 0. And then we are going to move to the next element. So the next element is 5, and since the count 1 is equals to 0, because of which we are going to set first as 5 and we are going to update our count by 1. Again, the next element is 5. Since this 5 is equals to the first element, because of which we are going to increase the value of count by 1. Then let's move to the next element. So then again the next element is 5. So again this element is equals to the first element, because of which we are going to increase the value of count 1 by 1, and then count 1 becomes equals to 3. The next element is equals to 6. As we can see, 6 is not equals to 5 and the count of second element is equals to 0, because of which we are going to update second to 6 and we are going to increase count by 1. So count 2 becomes equals to 1. The next element again is 6. So we are going to increase count 2 by 1. Again the next element is equals to 6. So we are going to increase it by 1. Again the next element is 6. So we are going to increase it by 1. And in this way, if you see, we have found the candidate element and the candidate elements are 5 and 6. And then in the confirmation cycle, all we have to do is we have to iterate on this array and we need to count the frequency of 5. So as we can see, frequency of 5 is 4 and the frequency of 6 is 4. And since the frequency of first and second is greater than n by 3, because of which we are going to say 5 and 6 are our candidate element and we are going to return 5 and 6. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find out the majority element and an array is given to us. So the first thing which we are going to do is we are going to find the candidate elements. So our candidate is equals to find candidate and we will pass the array to it. And then we are going to confirm whether the candidates are indeed the majority element. So for that, all we have to do is we have to iterate on the array and we have to check the frequency of the elements. So if element equals to candidate 0, then let's take a count as well. So let's say count 1 is there and count 2 is there and the initial value is 0. So we are going to increase count 1 by 1. And let's say if this condition is not satisfied, then we are going to check if element equals to the second candidate element. If that is the case, then we are going to increase count 2 by 1. And in this way, we have found out the frequency of the candidate element. Then we are going to check if count 1 is less than or equals to n by 3 and count 2 is less than or equals to n by 3. In such case, there is no majority element, because of which we can return -1. Otherwise, we are going to check if count 1 is greater than n by 3 and folks, n is equals to the size of the array. And let's take our answer as well. So let's say an answer is there with us. So all we have to do is answer dot append candidate 0, and the same thing we are going to do it for count 2 as well. So if count 2 is greater than n by 3, then answer dot append the second element. And then towards the end, all we have to do is return answer. Now folks, let us discuss find candidate function as well. So let's say we want to find out the candidate and an array is given to us. So over here we are going to take first and we are going to have a second element, and initially let us say we are going to set it to positive infinity, and then we will have a count 1 and count 2. Initial value is equals to 0. Then we are going to iterate on the array and we are going to check if this element is equals to the first element. If this element is equals to the first element, then let us increase count 1 by 1. Otherwise, we are going to check if this is equals to the second element. If that is the case, then we will go ahead and increase count 2 by 1. Otherwise, let us check if count 1 is equals to 0, in which case we have to reset the first element. So first equals to element and the frequency of this element is 1. And the same thing we have to do it for count 2 as well. So if count 2 is equals to 0, then second equals to element and count 2 equals to 1. Otherwise, if none of the conditions are satisfied, then that simply means it's a mismatch, in which case we will go ahead and decrease the frequency of count 1 and count 2. And then towards the end, all we have to do is we just have to return first and second. So that's the pseudocode for this problem, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So over here we have obtained our candidate element and then we are counting the frequency of these two candidate element. If the frequency of first candidate element and second candidate element is less than or equals to n by 3, then in such case there isn't any majority element, in which case we are returning -1. Otherwise, if the frequency of candidate element 1 is greater than n by 3, then we are putting first element into our answer list, and the same thing goes for the second element. And towards the end we are returning answer. Now let us look at the find candidate function as well. So for this, first and second are there, a positive infinity value, count 1 and count 2 equals to 0, and then we are iterating on nums array. If first equals to element, then we are increasing count 1 by 1. If second equals to element, then we are increasing count 2 by 1. Otherwise, we are checking whether count 1 or count 2 is equals to 0. If count 1 equals to 0, then we are updating first element and setting the value of count 1 equals to 1. And the same thing goes for count 2. If none of these conditions are satisfied, then we are decreasing count 1 and count 2 by 1. And towards the end, we are returning first and second candidate elements. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. We first find out the candidate element. Then we are iterating on the array to compute the frequency of these two candidate element. If the frequency of candidate element 1 and 2 is less than or equals to num size by 3, then we are returning -1. Otherwise, if frequency of element 1 is greater than n by 3, then we are pushing first element into our answer, and the same thing goes for the second element. And towards the end, we are returning answer. Now let us look at the find candidate function as well. So in the find candidate function, we have count 1 and count 2, which is equals to 0 initially. First and second, whose initial value is int max. Then we are checking if first equals to I. If that is the case, increase count 1 by 1. Otherwise, check if second equals to I. If that is the case, increase count 2 by 1. Otherwise, if count 1 has becomes equals to 0, then count 1 equals to 1 and first equals to I. And the same thing we have to do it for the second element as well. If none of these conditions are satisfied, then we are going to decrease count 1 and count 2 by 1. And towards the end, we are going to return our candidate elements. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. So that is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.